Hmm.
Hi dear students, I am Ashok Alishala, Assistant Professor of Chemistry, Kakatiya Government College, Hanamkonda. In this video, I am going to explain you one more tips and tricks with regarding oxoacids of the phosphorus. In this oxoacids of phosphorus, many of the students get confused regarding the basicity, oxidizing and reducing property of the oxoacids, and this video will help you to know all these things. Don't forget, watch this video till the end. See this video, oxyacids of phosphorus. Sometimes we call it as oxoacids or oxyacid, both are same, don't get confused. See, first of all, what your think is, while writing the oxyacids of phosphorus, I will tell you some techniques, just watch on this video. See, first you write the element is phosphorus. You write first the P. Then after that, in every oxyacids of phosphorus, there will be definitely a P double bond. Next, you write a tetrahedron, which is a basic unit in all oxyacids of the phosphorus. It is a tetrahedron unit. Then you write 3 bonds around the phosphorus in a tetrahedral manner. Now, this POH, when the number of OH groups in the oxyacids, that is POH, and this hydrogen is responsible for basicity of oxoacid. Now, this hydrogen, this is the bond directly, the hydrogen which is directly bonded to the phosphorus is responsible for its reduction property. Whereas the hydrogen which is linked through the oxygen to the phosphorus is responsible for basicity. Now, another one is, see the us, suppose phosphorus acid, hypophosphorous acid, like this. When the name of the acid ends with the us, you remember that the oxidation state of the phosphorus is in the lower oxidation state. And the salts of us acids are said to be the ide salts. That is phosphorus acid. Suppose you say the salt's name is phosphide salts. So in the similarly, ec acids, whenever the name of the oxoacid ends with the ec, and you remember the oxidation state of the phosphorus in the higher oxidation state. The salts of ec acids are ends with the 8. And for example, phosphoric acid, that is salt is phosphate salt. So that is, for example, phosphoric acid, sodium phosphate, magnesium phosphate, like that. Now, the oxoacids of the phosphorus mainly divided into the 3 parts. One is us acids, another is the ec acids, one more is the pyro acids. Let us see what are these. First, let us take the hypophosphorous acid. See, H3PO2 its formula, and our basic unit is the P double bond O. Then write the 3 bonds around the oxygen in a tetrahedral manner. Then write down the oxygens. See, already one oxygen we wrote here, and one more oxygen is left to be write here. And then after that, supply the hydrogens. So that only one hydrogen is oxygen is there. That's why we supplied hydrogen is here. Then after that, one more hydrogen is here, one more hydrogen is here. So that totally 3 hydrogens we wrote. Now see what happens. This is responsible for its basicity. Therefore, it is a monobasic acid. Because there are 2 hydrogens which are directly bonding with the phosphorus, it acts as what it is, a reducing property. See, this is 2 hydrogens are directly attached to the phosphorus. That's why, and this shows the reducing property. See, it is a monobasic acid. It acts as a reducing agent. It is also called postponic acid. The salts of this acid are called hypophosphites. Now, second acid, phosphorus acid in the acid series. See, H3PO3 its formula, and our basic unit is P double bond O. After that, you write 3 bonds around this phosphorus in a tetrahedral manner. Then supply the oxygens. See, among the 3, one is here and the 2 more are here. Then after that, supply the hydrogen. See what happened? 3 hydrogens are there. 1 hydrogen for this oxygen, 1 hydrogen for this oxygen, and 1 hydrogen is directly bonded. So that It is a dibasic acid because two OH groups are there. It also acts as a reducing agent because H3PO3 having the direct pH bond acts as the reducing agent, but it also acts as the oxidizing agent, weak oxidizing agent, because it is in the intermediate oxidation. It is a dibasic acid, acts as a reducing agent. It is also called Postponic acid. The salts of this acid is called, because it is us acid, the salts ends with the ite. Now another is the ec acid series. What are the ec acid? The first one is the phosphoric acid. What is our basic unit? P double bond. After that we have to write 3 bonds around the phosphorus in a tetrahedral. After that you supply the oxygens. Therefore one oxygen is here among the 4, 3 or we wrote like this. Then after that supply the hydrogen. So that what happened here? There are 3 hydrogens, all are in the OH. That's why it acts as only oxidizing agent. And here the OH bond, all H are in the form of OH. How many are the? 3. Therefore it is a tribasic acid. See, it is a salts are called phosphates. It is also called orthophosphoric acid. It acts as only oxidizing agent. It is a tribasic acid because all these hydrogens are in the OH form. Now let us see another one is a metaphosphoric acid. This is only the exception in our regular structure. Here the basic unit P double bond O is there, but instead of the 3 bonds it has only 2 bonds like this. And here the remaining we write the oxygen. The P double bond O, 2 oxygens are with the double bond and only 1 OH. That's why it is a monobasic acid. It is a monobasic acid. It acts as an oxidizing agent. Salts are called metaphosphate because the name of the acid ends with the ic. This acid or salts are not present as simple molecules but are often polymerized, and they are present in this polymerized form. And another one is the hypophosphoric acid. In these 2 phosphorus units are there, therefore 2 P double bond O units are there. After that, then write down the oxygens. Here 1, 2, 3, 4, 5 and 6 of the 2 oxygens already are in basic unit, and the remaining are bonded with this. And here another one is there is a P bond is there in hypophosphoric acid. And in this case, you remember one thing is here each phosphorus is linked with how many bonds? 1, 2, 3, 4, 5. In every oxo acid there must be 5 bonds. And here the P double bond 1 with 2 oxygen. Therefore the remaining bond is with other phosphorus atom. Now then supply the hydrogens. Therefore there are 4 hydrogens. 4 hydrogens are bonded to through the oxygen atom to the phosphorus. Therefore it is a tetrabasic acid. There is no direct pH bond. That's why it acts as only oxidizing agent. See, it is a it is a dibasic. It is wrong. It is a tetrabasic acid. It is a tetrabasic acid, not dibasic. It is a tetrabasic acid. It is a tetrabasic acid. Acts as oxidizing agent. Salts are called hypophosphates because the name of the acid ends with ic, but the prefix is hypo. The same prefix is carried in the name of the salt. Now let us see. The other one is pyrophosphorous acid. Here also 2 phosphorus oxygen, 2 phosphorus are there. Therefore you write P double bond O 2 units. Then supply the oxygens. See, I'll tell you. This is here. Whenever you get the pyro, here instead of P it is O actually. There is a small here. This is not P. This is O. This is going to be the pyrophosphorous acid. Whenever you get the pyro, the term, you remember that there is an oxygen between the 2 phosphorus atoms. Then how many oxygens completed? 1, 2, 3 are there. Among the 5, 3 are there. And here let us see what happened. There is 2 oxygen, 2 more oxygens. What happens? How many oxygens are there? 1, 2, 3, 4, 5 are there. And for this, when hydrogens are added, the oxygen is taken by these 2 hydrogens, 2 hydrogens. From this structure you can understand it is a dibasic acid because only 2 hydrogens are through oxygen. And but there are 2 hydrogens are directly bonded. Therefore pyrophosphorous acid acts as a reducing agent also. It is a dibasic acid, oxidizing as well as reducing agent, because there is a direct pH bond is there, OH bond is there. That's why it acts as both oxidizing as well as reducing. Salts are called pyrophosphites. See, the prefix is here also. It is, you remember, all these are the pyro, not P. Pyrophosphorous acid, the prefix is continued in the name of the salt also. I told you, when the name of the acid ends with us, here the name of the salt ends with it. Now, see another one, pyrophosphoric acid. I already told you, whenever you get the pyro, there is a bond between the two there is an oxygen between the two phosphorus atoms. See, this is going to be the oxygen. Now, 1, 2, 3 bonds are there, remaining 2 bonds is here. Every phosphorus in oxoacids of the phosphorus having 5 bonds. Among the 5, there will be double bonded oxygen. Then supply the oxygens. These are the 4 oxygen. How many? 1, 2, 3, 4, 5, 6, 7. Therefore, 7 oxygens are there. Then now supply the hydrogens. Therefore, you have the hydrogens. Therefore, it is a tetrabasic acid. Acts as an oxidizing agent. Salts are called because the name is ends with the ik. Here the salt name is 8. The pyro, here also pyro, it is not P, it is O. Here the pyro is continued in the even in the name of the salt. Now let us the last one is the peroxyphosphoric acid. It is very similar to, here the formula is going to be the H3PO5. The formula is going to be the here H3PO5. The formula H3PO. It is similar to the phosphoric acid or orthophosphoric acid, but only thing is there is a peroxy bond. This bond is called peroxy bond. This is also tribasic acid. It acts as strong oxidizing agent. Salts are called peroxyphosphates. Okay, now let us see this one. This chart, this will give you the complete picture of this one. These are the 8 oxoacids of the phosphorus. Hypophosphorous acid, its structure formula is H3PO2, oxidation state is +1. Basicity is 1, acts as only reducing agent. Whereas phosphorus acid, H3PO3 +3 is oxidation state, basicity is 2, and it acts as both oxidizing as well as reducing. Orthophosphoric acid or phosphoric acid, H3PO4, oxidation state is +5, the basicity is 3, then it acts as a oxidizing agent. Metaphosphoric acid, HPO3, +5 is oxidation state, basicity is 1, it acts as an oxidizing agent. Hypophosphoric acid, H4P2O6, and here oxidation state is +4, then the basicity is also 4, acts as only oxidizing agent. If you go for the pyrophosphorus acid, H4P2O5, the oxidation state of the phosphorus is +3, and but basicity is 2, and it acts as both oxidizing and reducing. It acts as both oxidizing and reducing agent. You have to remember here why the basicity is 2, even though there are 4 hydrogens. I explained you in the structure. Pyrophosphoric acid, H4P2O7 +5 is oxidation state. Basicity is the 4. It acts as a oxidizing agent. Peroxyphosphoric acid, here there are 5 oxygens, even though the oxidation state is +5, because there is a peroxy bond. The oxygen atoms which bonds with the peroxy bond will have only -1 oxidation state. That's why the oxidation state is +5, the basicity is 4, and it is an oxidizing agent. What you have to remember, here the number of hydrogens, whatever the present in all oxoacids, are not equal to their basicity. Here it is 3, but basicity is 1, but here 3, it is basicity is 2. Here it is 3, it is basicity is 3. Here 1, therefore 1, it is no problem. And from here hypophosphoric acid 4, okay. But whereas pyrophosphorous acid, 4 hydrogens are there, basicity is 2. These things you have to remember how to write their structure with this tricks and tips. Okay, thank you for watching. Thank you for watching this video. And if it is useful to you, if you feel it is useful to you, just share with your friends so that it will be useful to all of you. Thank you. Thank you for watching this one.